Okay, in this video we're going to take a close look at partitive or sharing division. In partitive division, you're given the number of groups and the goal is to find the number in each group. So, I've given you an example. 5 boys bought 15 baseballs. If they share all of the baseballs equally, how many baseballs will each boy get? And you can see that I've given a model to illustrate that we have the total number of baseballs. We know how many boys there are. What we did not know is how many baseballs each friend would receive. And I illustrated that for you here. We have 5 friends, and we split or shared the 15 baseballs, and it ends up that each friend gets 3 baseballs. So let's take a look at how a student would learn how sharing or partitive division works. In this page, I have shown a picture of the same problem that I just read on the previous page. We have 15 baseballs and we have 5 people. When children first learn how to share using division, they use a one-to-one share. In other words, they would take each item and they would just give everybody one item until there were no items left. So they pass baseballs out until we're out of baseballs. When you're done and there are no baseballs left, well, or you cannot go back through and share again, then you have your answer to your problem. So that's what we're doing now. We're just sharing one baseball at a time until we don't have any baseballs left or we can't share again. So we end up with every person chose to have 3 baseballs and everyone has an equal amount of baseballs. So the answer to the problem is every person gets 3 baseballs. We have to understand that division creates equal groups. So we can look at this in another way without doing a one-to-one share. Children who learn division after they've learned a one-to-one share need to look at this problem from a standpoint of sharing the items without actually passing the items out, so that they can better understand how many each person will receive without having to actually pass one item to every person. That process is good until the dividend becomes a very large amount, and then it's very hard, or it takes a very long time to give a one-to-one share. So we could look, we have 15 baseballs, there are 5 people. We can use our knowledge of multiplication to help share these baseballs with 5 people. So we could think that, well, if there are 5 people and we know 5 times 3 equals 15, so we know that each person would receive 3, just like we did before. And in this case, we won't actually share or pass them out. We could just circle 3 baseballs for each person. So 3 for that person, and then so on. We could do 3 for the next person, and it would show that each person would receive 3, or it would be 5 groups of 3. Let's move forward and look at the next slide. What happens though if the items that you're sharing actually have place value? Before we were talking about baseballs, and that can be shared in a one-to-one share. But here we have money. And money is a little tricky because money has place value. And place value is important when we teach children division, because in the base 10 number system we use place value. So let's think of this problem in terms of sharing. We have $115, and we have to share that $115 with 5 people. Well, what do you do when you have one $100 bill or one $10 bill, and you need to give that to 5 people? So we have to come up with a plan. If I ask children to share this money, a lot of children would start here in the ones place. And that's okay. They can actually do that. They could say, well, there are 5 ones, so everyone could get a $1 bill. But for the purpose of this video, and because we want to transition children into an algorithm later, I would encourage them to possibly start sharing in the hundreds value. So how are you going to give one $100 bill to 5 people? Well, we know that we can take that $100 bill and we can exchange it or trade it for 10 different $10 bills. So now we don't have a $100 bill, we have 10 $10 bills, because we did not have enough $100 bills to give everyone a $100 bill. So we traded it for $10 bills, and now we have enough money, or $10 bills, to give everybody $10 bills. So I will trade, or not trade, I will now share the $10 bills with each person. And I will just keep sharing until we either have no more $10 bills or we do not have enough $10 bills to continue sharing. So there's where we are. We gave everybody 2 $10 bills, and now we only have one $10 bill left. Do I have enough $10 bills to now share the $10 bills again with every person? Well, no, I only have one $10 bill. So we now need to figure out what to do with one $10 bill so that we can keep dividing this money. Well, again, we know that $10 bills can be exchanged for $1 bills. So let's take this $10 bill and we're going to do what we call decompose. We're going to decompose the $10 bill into 10 different $1 bills. So we have an equivalent value, it's just represented in a new format. So we can take these $1 bills. Do we have enough dollar bills to share with 5 people? Sure we do. We have way more money in $1 bills than we do people. So now we can begin sharing again. And we will just pass out the $1 bills until everyone has all of the money. Now, while I'm passing this out, could we have looked at that money and decided how many dollar bills could each person get before we actually started sharing the money? Well, before I started rearranging these $1 bills, there were actually 15 $1 bills in the ones column. And if there were 5 people, just like in the baseball problem, and there were 15 $1 bills, well, we could have thought about how many $1 bills could each person get. Well, again, we know 5 times 3 equals 15, so we should have known that each person gets 3 $1 bills. And now you can see that each person ended up with the same or an equal amount of money, and the money they ended with each was $23. So we shared the money with 5 people equally. Now, that was the first step in sharing. Let's take a look at a little bit more abstract, or a little bit more of a numeric way of looking at this process. We have the same problem. We have $115. We're sharing that with 5 children. And I'm taking you through the steps that I would do with my children in class as well. We would start with a picture or a manipulative in their hand, such as money. We would share, and then we would move into a more numeric representation. And then finally, in the end, we'll get to in a minute, we'll look at the algorithm for division. But let's go here and let's look at the symbolic or the numeric representation. So we have one $100 bill. Do we have enough hundreds so that every person below can get 100? Well, no, because we would need at least 5 100s to give everybody a 100. So we cannot share this 100 with 5 people equally, so we need to decompose the 100 to make a total of 11 tens, because we broke our 100, or we decomposed our 100 into 10 different tens, and there was already 1 10, so now we have a total of 11 tens. Do we have enough tens to give everybody below a 10? Well, yes. If we have 11 tens and there are 5 people, how many tens can I give each person? Well, I know 5 times 2 is 10, so I could give him 2, I could give him 2, and so on. So let's do that. If I give out 10 of my tens, it will leave me with 1 10 left. And by the way, I'll show you that. We gave 2 tens to this person. We gave 2 tens to this person. We gave 2 tens to this person. 2 tens here. And 2 tens here. Which is a total of 2, 4, 6, 8, 10 different tens. So 11 minus 10 leaves me with 1 10 left, and now I need to decompose that 10 because I do not have enough tens left to share. So I'll decompose that 10 into a total of 15 ones, and now we need to look at, we had 15 ones, and we need to share 15 ones with 5 people. So I will give everybody 3 ones, which used all of my ones, leaving with nothing left over, and that gives everybody 3 ones. 3, 6, 9, 12, 15 ones. So we used all of the ones with no ones left, and we gave everybody their money. So everybody ended up with 2 tens and 3 ones, or what we would say, $23. Now, let's look at moving that into the final stage, or the most abstract of the stages, which is the algorithm for division. We have the same problem. 5 students will share $115 equally. This is the process that many teachers or parents would begin students with when they start teaching division. This should always be the last stage of the development. You don't want to give children this algorithm until they have proven that they understand the 2 stages before this. So now let's look at the algorithm and decide or figure out how this is a representation of what we did with the picture and then with the chart before. So we have 5 people. We have a total of $115. We have 100. Do we have enough hundreds to share with 5 people equally? No, because we would need 5 hundreds. So teachers would tell people, or sometimes parents would tell students, they would say, well, 5 will not go into this 1, so you put a 0. Well, we need to be more detailed than that, because we know this is 100, and 5 will fit into 1. But again, you need to make sure that you're telling children that you're not actually putting this 5 into the 115. Division is not a putting together process. In fact, it is a taking apart. It is a decomposition process. You're not going into the 115. In reality, you're taking away or taking apart the 115. So, do you have enough hundreds to give everyone a 100? No. So we need to look at taking this 100 and decomposing it down. So we're going to take our 100. We said that we cannot give everybody a 100, so we subtract out. And now we're going to turn the 100 into, here it comes, it turns into 11 tens. When you bring down, what you really did is you took the 100 and you turned it into 10 different tens, plus the 110 that you had created 11 tens. Now, do you have enough tens to give everyone a 10? Well, sure you do. You have 11 tens, you have 5 people, everyone can get 2 tens, and that will use up a total of 10 of your 10s. So we have 1 10 left. Well, here's the problem. Can you give this 10 to these 5 people? Not like it is. Not as a 10. You cannot take this $10 and give it to 5 people without then decomposing that 10. So bring down the ones. It will turn the 10 into 15 ones. Now, again, we have 5 people, 15 ones. Can I give everyone some $1 bills? Well, sure, I can give them all 3, because 3 times 5 will give me a total of 15. So I give everyone 3. That used up 15 of my 15 ones, leaving me with no ones left over. We need to make sure that we don't tell children the 5 goes into the 1. Well, no. The 5 goes into 11. Yes, it goes twice. We need to avoid that, because if we're telling children the 5 goes into the dividend, that would mean that the dividend is increasing. But reality is you're taking 5s out of the dividend, because division is a repeated subtraction process. So let's be sure that we share things correctly. Let's explain the algorithm correctly using a partitive or a sharing process. When we go back, we should always develop stages of sharing among children. We start with developing what partitive division is. You need to know, it gives you the number of groups. And the goal is you're looking for how much is in each group. That's very important. Now we look at the slide with the baseballs. This is how students learn to share, 1 baseball at a time, and then they begin grouping. So we then have to move past that idea into a place value concept, where you have to decompose units of a higher place value into an equivalent form of a lower place value, so that you have enough to share. After working with a hands-on manipulative in real life, we would transition into a more numeric procedure where you have more number symbols involved, and we connect those symbols for the children so that they can start to see the connections with the division algorithm, which would be the final process of sharing. And again, we'll run through this real quick. Did I have enough $100 bills to give everyone a $100 bill? No. So I broke them into 11 tens. Do I have enough $10 bills to give everyone $10 bills? Sure. Everyone would get 2 $10 bills, because that will use up 10 of the 11 tens that I actually have. It leaves 1 $10 bill left. We do not have enough there to share. We need to then decompose into ones, and now we have enough ones to share, so everybody gets 3 ones, leaving none at the end. Now, in the next video, we're going to look at measurement division and see how that division concept is different from a partitive or a sharing division concept.